Going with the ninth question, it says that there is a right circular cylinder encloses a sphere. Now, what does the term right circular cylinder mean? You're going to have these terms coming up in the next exercise. A right circular cylinder means that is standing upright to the surface. Okay, if a cylinder is this is the surface, this is what is considered to be the upright cylinder or a right circular cylinder. Likewise, you'll have words, sentences or questions coming up like a right circular cone. That means it is standing upright like this, or it is standing either this way. Okay, because it is perpendicular to the surface. Okay, the height is perpendicular to the surface. Here also, this is the height of the cylinder. It is perpendicular to the surface. This is the height of the cylinder, which is perpendicular to the surface. Okay, so this is what is called as a right circular cylinder. Okay, now this says right circular cylinder encloses a sphere. That means there is a sphere inside it of radius r. The radius of the sphere is given to me as r. Okay, fine, take care. Now then they're asking me find the CSA of the sphere, surface area of the sphere, CSA of cylinder, and ratio of the areas of the A and B. Okay, so now when we are considering the CS, okay, sphere, I know the sphere radius is given to me as r, so it's quite very easy for me to calculate the surface area. That is 4 pi r square. That goes as 2 times of 22 by 7, or pi, it remains like that itself. Because we don't have the value of r, we're going to keep pi as it is. 4 pi r square. It would remain the same. Okay, that's one thing. The second thing that they asked is CSA of cylinder. Okay, now what is the formula for the CSA of cylinder? It is pi. It is going to be 2 pi RH is the CSA of the cylinder. Okay, 2 pi RH is the CSA of the cylinder. Now this is the cylinder in which the sphere is standing. The sphere radius is given to me as r. So the cylinder radius is also r, isn't it? Okay, because it's exactly, the sphere is fitting into the cylinder, so they're both same. So cylinder radius is equal to r. What about the height of the cylinder? The height of the cylinder is going to be, if this is the radius, okay, likewise if you see, if I'm considering this is the radius, so also from the center towards one end will also be the radius, isn't it? And center towards the other side is also the radius. So the height of the cylinder is r plus r, which is equal to 2r, isn't it? So the height of the cylinder is 2r I have. So height is equal to 2r I have in here. Very good. Then I'm going to start substituting in here. So 2 pi r into 2r is what I'm going to get here. So that goes 2 to 4 pi r square I have. Okay, now fine. This is what I have in here. Okay, then they said that the last one is ratio of this. Now the ratio of the surface areas. So sphere to cylinder surface area I'm supposed to do. That is 4 pi r square upon 4 pi r square is what I have here. Now what's going to happen when I have these two surface areas being divided by each other? Very simple, I can say that because they are exactly the same, they are going to cancel out each and every term, and then you are left with 1. 4 pi r square, you are left with 1:1, or the ratio between them is 1, you can say. Okay, that's brought us to the end of the second exercise.